Good morning, students. We are going to continue the last lecture, that is a recap of Unit 1. Okay, in today's lecture, what we are going to see what is data mining, what are the data mining techniques which are available. Data mining has become an essential tool in modern chemical engineering for extracting meaningful patterns and trends from complex data sets. When they say complex data sets, that means the data obtained from the complex equation. Okay, so the any data we cannot say the number is complex just by mere seeing the number, right? So the complex data set means it relates one variable to the other variable. It has been correlated. Okay, so data mining has become an essential tool in chemical engineering for extracting the meaningful patterns and trends from the complex data sets. So what is the effect of one variable on the other variable? So because of that another data would be obtained. So that data we would have collected and try to find the extract meaningful pattern and trends. So exploring the data mining is to explore the things. With the advent of advanced sensors, automation and computational techniques, large volume of data are continuously generated in the chemical process. As we know, for even for a reactor, when you have a dependent variable and an independent variable, if you change the independent variable, what would be the effect of the dependent variable? Okay, so analyzing these data sets effectively can improve the process efficiency, optimize the product quality, enhance the safety, and drive the innovation. So, from the starting point, still now, for all the process what we are doing, finally it will help you to obtain the process efficiency, optimize the product quality, optimize the process, that means, and then enhance the safety, and also it leads to a research and innovation. So this all we are doing for this machine learning techniques, okay, to implement in order to obtain the cost reduced process, optimized process, energy saving process. Hope you understood that one. This document explores the key data mining techniques applicable to chemical engineering, emphasizing their importance, methodologies, and practical applications. Importance of data mining. Okay, what is the advantage of using the data mining? Okay, that's what we are going to see. Okay, efficiently mining this data. Okay, efficiently mining from bad data. Chemical engineers process vast amount of data from lab experiments, industrial process as well as simulation. So efficiently mining this experimental data or laboratory data or simulation data allows engineers to detect the anomalies, that means deviation of data and faults in processes, optimize the operating conditions for better yield and efficiency, predict equipment failures and maintenance needs, important product formulation and quality control, reduce waste and environmental impact. So by doing efficiently mining this data will help you to obtain all these things. Okay, reduce the waste and environmental impact, improve the product formulation, predict the equipment failure, optimize the process, and identify the deviation of data. So by leveraging the data mining techniques, chemical engineers can move from reactive to proactive decision making. So reactive means once it has been happened and then we are reacting back. Reactive to proactive, that means we understand this will happen and proactively we measure take the decision. Okay. So for example, weather condition, which I already told you during the unit 1 coverage, but anyhow I just would like to recap the things. For example, you have a weather condition and we know the pattern, how the wind direction is there, and how the cloud formation occurs on the sky. Okay, so when you have this data, the people will predict and tell you tomorrow there will be a heavy rainfall in this particular district or zone. Okay, so the people will be alerted and they will take a decision. Okay, whether they can send to the kids to the school or the even the government will take a decision, okay, regarding whether that the leave need to be declared and so on and so forth. Okay, so the proactive decision making enhancing the overall process performance. So data mining techniques encompasses several techniques for discovering the pattern and trends. So what are the classification? The classification goes like this: decision tree, support vector machine, and neural networks. So which we have told actually in the last video, the artificial neural network. So the neural network used for deep learning based classification task. Example application: predicting whether a batch of the chemical product will meet quality specification based on the input process parameters. Okay, so deep learning based classification techniques, we go for a neural network. Support vector machine, effective for complex or non-linear classification. For example, the second order reaction, or else I can say when the pollutant comes from the stationary point or the standalone point, for example from the industry or from vehicle. So when I want to find the pollutant concentration at different location x, y, z on the sphere or the environment, okay, then we can go for a support vector machines. Okay, so decision tree useful for hierarchical decision making and interpretability. So the classification of data mining, okay, are used to categorize the data into predefined groups. Okay. So I'm coming to the clustering. Clustering, K mean clustering, hierarchical clustering, density based spatial clustering of application with noise. These are available. Coming to the regression analysis, regression models like linear regression, multiple regression. Linear regression, the relationship between the variables are linear, suitable for simple relationship. Multiple regression, use multiple factors influence the outcome. Okay, so multiple variables has been correlated. For example, you have a multiple independent variables. Okay, so the response of one response. Okay, so we need to go for a multiple regression and a polynomial regression. So it's a quadratic or a, what you call power 3 or power 4. Okay, capturing a non-linear trend. Okay, predicting the yield of a chemical reaction based on temperature, pressure, and reactant concentration. So association rule mining. So association rule mining identifies relationship between variables and large data sets. In large data sets, there is a priori and FP growth algorithm are commonly used, which I told you. So discovering correlation between the raw material properties and final product quality in polymer manufacturing. So next one is a partial component analysis. So the principal component analysis, partial least square method also we have seen in the unit 2. Okay. Since it's a recap, just go back and see what are the examples which are given for principal component analysis when we need to go for a partial least square regression analysis. Okay, so the principal component analysis reduction technique that helps in identifying the most significant variables. Okay, identifying the most significant variables in the data set, making data analysis more manageable, reducing the number of process control variables while retaining the essential information in the chemical manufacturing plant. So this is the application. So is a dimensionality reduction technique. Principal component analysis is a dimensionality reduction technique. Underline the word dimensionality reduction techniques. That means the number of variables that has been reduced. So the number of variables can be reduced only by means of the less that particular variable is having a less effect on the output variable. That is a response. So principal component analysis is a dimensionality reduction technique that helps in identifying the most significant variables in a data set. Identifying the most significant, leaving out the unwanted variables. That's the meaning. So coming to the application of data mining, okay, applied across various areas in chemical engineering. One is process optimization, fault detection and diagnosis, product quality control. In process optimization, by analyzing the historical data, chemical engineers can identify the optimal process condition, reducing cost and improve efficiency. In fault detection and diagnosis, data mining helps in identifying the abnormal patterns and that may indicate the process fault or equipment malfunction, enabling the predictive maintenance strategy. So, data mining will help in identifying the abnormal patterns. That is very, very important. It will identify the abnormal patterns. That means deviation of data, outliers that may indicate the process fault or the equipment malfunction, enabling the predictive maintenance strategy. Coming to the product quality control, by examining the historical production data, engineers can determine the factors, which are the factors which are affecting the product quality and adjust the process parameters accordingly. Environmental monitoring as well as the drug development and chemical formulation data minings are helpful. What are the challenges in data mining? Data quality issues, incomplete, inconsistent or noisy data can affect the accuracy of results. Complexity of chemical processes. Chemical processes involve intricate interaction, making data analysis challenging. Okay, computational requirement. Processing large data sets requires significant computational resources and expertise. Okay, so let's say you have process modeling and simulation. In process, we are using Aspen Plus and Aspen ISIS. So, which will help you to find the optimized for process conditions. Okay, how this system works? The system works based on the models, and it will have a complex non-linear relation equation need to be solved. Okay, and then it will try to solve and it will give you an optimized point. When you see the computational requirement here in the machine learning, we have been giving the data and train the system. Okay, by means of machine learning algorithm. It may be with the relation between the dependent and independent variables, or there won't be any relationship between the dependent and independent variables. We may give a labeled data or we may give a unlabeled data. So, for example, artificial neural network, so we have a hidden layer and we have a output layer and we have a top layer. Okay, so you hope you understood what I am trying to say. Interpretability is one of the challenges. Some advanced machine learning models lack interpretability, making it difficult for engineers to trust and apply the results. Interpretability. Okay, how we interpret. So you should not interpret it wrongly. For example, I am conveying something. If you interpret something, then interpret wrongly, what will happen? Your understanding may be different, and there won't be any point. Actually, there is no point of a. Oh, there is a lack of communication or because of misunderstanding. The interpretability is different. Future trends and conclusion. The future of data mining in chemical engineering is promising with the emerging trends such as integration with artificial intelligence, AI-driven models can enhance the predictive capabilities, big data analytics, cloud computing, and high-performance computing enable large-scale data processing. So, big data analytics, cloud computing, and high-performance computing enable large-scale data processing. So, when we have a big data, that means a large amount of data. So, when you go for testing, training, and the thing, obviously it will learn fast. It will learn more because the deep learning is a part is a subdivision of machine learning only. Okay, so the big data analytics which talks about the large amount of data and then coming under the analytical things and analyze the things. Okay, so real-time data mining, advanced sensors and the IoT devices allow real-time monitoring and decision making. This I will tell you actually. So during when I was working in a different institute, we have planned to have a IoT enabled what you call a biogas plant. I've installed a biogas plant from a nearby hostel for one of from in one of the private institute where I worked earlier. So what I did is that I just take down the cow dung. I've taken some 20 what you call 2000 is a 10,000 liters of container and then filled with cow dung and then add some vegetable waste every day which has been collected from the hostel. Then I try to produce biogas, that is a methane. Okay, so that will have a high calorific value that you can burn the things. So what is our objective is to make sure how much is the amount of methane produced on every day. Okay, so when you put it inside this cow dung waste as well as the vegetable waste, obviously it will digest the cow dung vegetable waste and then produce the methane gas, which is having a high calorific value, which can be used as a gas to heat up the what do you call to eat the for food purpose eating the eat source. Okay, for example, what we did is that we may prepare the coffee or tea. It will burn for 20 minutes. Okay, so for 20 minutes burning of gas cylinder, can be saved when you try to you generate biogas from 20,000 liters of container. Okay, so just imagine it's like a syntax stack. Okay, it's not a 20,000, actually is a volume is around 10,000 liters, I think. Okay, so please imagine. Okay, if that particular thing, why I'm trying to say this example is that we every time we need to go manually and try to find whether the biogas has been produced or not, because it has been placed in such a way that when the gas has been produced, it will lift the gas. The gas will lift the container. It will go up. Okay, so it will be placed in such a way that it will be floatable material. Okay, that means one of the can will be floatable. So once the biogas has been produced, it will push the thing. So the water level will be raised. Okay, the water level will be raised and it will go at the top. So it will push the thing. Okay, so when you have IoT sensors, it will tell you how much is the amount of gas which has been produced, volume of gas produced. Then we can, once it has been fulfilled, then we can go and collect the gas or utilize the gas. Okay, so the real-time data mining, advanced sensors and IoT devices allow real-time monitoring and decision making. So the conclusion of this part is that as data-driven methodologies continues to evolve, chemical engineers must embrace the data mining techniques to remain competitive and driven innovation. So next part, what we are going to see is that use of data analytics in process optimization as case study. So one of the case studies, manufacturing industry reducing defect in production. The background is a leading automobile manufacturer faced challenges in maintaining the consistent product quality due to defect in the assembly line. So frequent defects lead to increased rework costs and reduce the customer satisfaction. So the implementation of data analytics, the company deployed machine learning algorithm to analyze the sensor data from production equipment. The real-time monitoring system were installed to track the deviation such as critical parameters such as temperature, pressure and machine vibration. Historical defect data was used to train the predictive models to identify the early warning sign of defects. So manufacturing industry reducing the defect in production. So they are deploying the machine learning algorithm to analyze the sensor data, real-time monitoring to track the deviation. Historical defect data was used. So this is how the implementation of data analytics has been carried out. So the outcome is 30% reduction in defect rates was achieved within 6 months. So analyzing the data and use the machine learning models will help you to reduce the defect rate by 30% within the 6 months. Predictive maintenance helped to prevent machine breakdown, reducing the downtime by 25%. Improved product quality resulted in higher customer satisfaction and cost saving. Coming to the case study 2, let's imagine a healthcare industry. Okay, the background is a hospital network looking to improve the patient care by reducing the length of the hospital stays and minimizing the readmission rate. So for which what they are doing actually here, the healthcare industry, if they have the people have been stayed quite long and the patient is frequently visiting the hospital, is a profit, right? But at the same time, what we are for the patient point of view is a, what do you call it? Is a cost is a cost is getting reduced. Cost there is a lot of cost involved. Okay, for them, and health is also need to be maintained. Okay, not to avoid that, what they are doing here, implementation of data analytics. Patient records were analyzed using AI-driven predictive models. Okay, so what is the previous record? What are the data? What is the current scenario? But nowadays, we go to the multi-specialty hospitals, they are collecting your data. Okay, for example, I used to go to eye checking for every 6 months. So in that case, what they do for every 6 months, what is my power, whether what is the eye pressure, whether what is my blood pressure, everything, all the data they are just collecting, because as they are patient, they are collecting, they have a backup. So this 6 months before you have this power, now the power has been increased, or there is a very little chances of power is getting reduced. But if you see, for me, for my eyesight, there is a short sight actually previously. Now they have a long sight also, that they have a problem. Okay, so the short sight means I can see only a very close object. Okay, so myopia and hypermetropia. So that I don't want to go into that time. What I am trying to say is that the people have been collecting the data as a patient that can be used for some other purpose. So they know already how the trend is, whether the power has been increasing every year or is there is a ups and down. Okay, so that will help you to understand the behavior, how the your health has been monitored, your health has been changes. Okay, that is monitor. Okay, patient records were analyzed using AI-driven predictive models to identify the risk factors associated with prolonged hospital stays. Electronic health records were integrated with real-time monitoring devices to track vital signs, important signs, and alert medical staff to crucial changes. As I told you in the while covering this part, just have a what you call the sensor which has been connected to the hand or something. So when you go for jogging or when you are walking, it will help you to it will record the what is your blood pressure, what is your pulse rate, what is your heartbeat, okay, what is your sugar content level in blood. This all can be monitored. Nowadays is very common. This type of sensors is already available in market. Okay, so when the people have been checking, monitoring this particular data in the hospital from the hospital, obviously they will give you alarm. That means your heart beat is getting down. Just come and come to the thing. So they will give you that is it. So data-driven decision support systems were implemented to personalize the treatment plan based on historical patient data. To analyze the word personalized treatment plan. Okay, so nowadays we're talking about industry 5.0. So the industry 5.0 is nothing but actually the personalized treatment. It is coming under industry 5.0. No need to go for a hospital and try to do the things because they will monitor the system from there and they will give you what you need to do. Nowadays, it's very common. If you go to the Western countries, putting insulin on their body, they won't go for the doctors. The doctors will train you how to put the injection on your body. When the sugar level is getting down, so you can able to inject yourself because this is a very common, become very normal nowadays. Even in India, if you go to any special gathering where the people have been more than 1,000 people have gathering, you could be able to see sugar-free tea or sugar-free coffee are available. Why? Because many people have been having diabetic patient, so it's very common. So now we are following the Western culture. Obviously, we have come up with different diseases. Okay, so obviously, what we need to follow this type of advanced technique also will be very common in India, like developing nations. Okay, so coming to this point, what is the outcome? A 20% decrease in patient readmission rate was observed because of collecting the data from this spot. Length and hospital stays were reduced by an average of 1.5 days. So, because of this advanced monitoring system. Okay, so conclusion of case study 1 and 2. This case studies highlight the transformative impact of data analytics in optimizing the process and improving the quality across industries. By harnessing the power of data, business can make informed decisions, enhance operational efficiency, and deliver superior product and services. By harnessing the power of data, so if we have data that you could be able to do take decision. So I can say some other example. So okay, apart from this, the realistic life. Just imagine what the Google is doing, what the Facebook is doing. They are collecting the data. Even what the Ch22088, what the DeepSeek is doing, they are collecting the data. What is your requirement? For example, I am searching in Google. Okay, I want to buy a what do you call it, pant. Okay, which brand? Okay, let's say you have a auto or okay any brand. Okay, so you just I want to wear a Van Heusen shirt or something. Just imagine. So the same data will be reflected in Facebook. That means it will give you ad. So that means you have been monitored. Okay, the what is your requirement? So obviously it has been reflected in the Facebook. So imagine. So when you have given a lot of data, so it can be monitored by them and it will give you the things. That means one side maybe you find it very what you call uh, you find it actually is not safe or something revealing the information. But at the same time, on the other side, if you look into it, that means what is we needed is has been reflecting as such. So we don't need to see and explore in Facebook, because what we searched in Google is also automatically reflecting the Facebook. So that will be our like section. So this type of information. So what I am trying to say is that the data is very very important. With that data, you could do anything. Okay. So obviously we are doing this machine learning algorithm, utilizing the machine learning algorithm, and then data analysis. Okay, this is all for the purpose of make sure the system works at the optimized condition. Okay, so that's the whole thing. So coming to the data analytics case study, so which we have already discussed. Okay, optimize reactor performance in petrochemical industry. A petrochemical plant faced challenges in maintaining the optimal reactor condition, leading to variable product quality. So what they did actually, advanced process control system were integrated with real-time data analytics. So to monitor the reactor condition. Predictive analytics was used to optimize the reaction parameters such as temperature and pressure and concentration. Historical production data was analyzed to identify the patterns that contributed to the inefficiency. Because of doing so, implementation of this data analytics, it could be able to reduce 20% reduction in energy consumption. Okay, product quality variation were minimized, leading to the improved consistency. Predictive maintenance reduced unplanned downtime by 30%. So the case study, I will just skip this part, the case study 4 and 5, and we will go to the case study 6, corrosion prediction and prevention in chemical plant. When you see here, a chemical processing plant experiencing the frequent corrosion related failures in pipelines and equipment, leading to safety hazards and maintenance costs. So the background is chemical processing plant experience a corrosion related failures in the pipeline. So when the fluid has been passing through, whether maybe a gas contains hydrogen sulfide or even a crude oil which contains hydrogen sulfide in it, obviously will corrode the pipeline. Okay, so that will lead to a safety hazard. Corrosion happens, the strength of the pipeline is getting reduced, so there may be a leakage takes place, it's a loss of money, or there may be chances of fire also. Okay. So sensor-based monitoring system were deployed to collect the real-time data on the corrosion rate. Predictive analysis models were developed to forecast the corrosion rates based on the environmental condition. Data visualization dashboards provide actionable insight for maintaining the maintenance scheduling. Outcome is 40% reduction in corrosion related equipment failures was observed. Maintenance costs were reduced by 25% through proactive measures, interventions, enhanced plant safety and extended equipment lifespan. So the conclusion here it goes like this: the role of data analytics in driving the process optimization and quality improvement in chemical engineering. Okay, in chemical engineering, by harnessing the real-time monitoring, predictive analytics, and machine learning, chemical industries can enhance efficiency, reduce waste, and ensure consistent product quality. As data analytics continues to advance, its application in chemical engineering will further contribute to innovation and sustainability. Thank you for your patience of recapping the unit 1. Hopefully, we will go on to the unit 2 recap as well. Okay, so that it will be better for you to understand. I mean, do these videos. Okay, before you go for your fact 1. I stop it here. Thanks for your time. Thanks for listening.